The following question states that in the addition polymer polypropene, what is the simplest ratio of carbon atoms to hydrogen atoms? So he's talking about polypropene, which is an addition polymer. Now polypropene, and let's look at propene first. Propene has 3 carbon atoms, and it's going to have a double bond in one of the carbon atoms because it's an alkene. And let's draw all the other bonds, 3 bonds with hydrogen. This one is short of 1 bond, so that's hydrogen. This one needs to make 4 bonds, so 2 would be with hydrogen. So this is a formula of propene. Now to make an addition polymer called polypropene, the rule is that you need to first identify the double bond, put a box around it just for clarity's sake, and make sure that redraw this molecule. So I'm going to redraw this molecule. So there's a carbon, double bond carbon. One of the hydrogen is on top of one carbon atom, and the other hydrogen is on top of the other carbon atom. So let's draw those hydrogens. And what you're going to do is, this hydrogen is on the right hand side. It's drawn on the right of this carbon atoms. Make sure you don't draw anything to the right of this carbon atom. So what you're going to do instead is, you're going to pick this hydrogen and you're going to bend it and draw it below this carbon atom. So it's going to go underneath this carbon atom. Similarly, over here there's a CH3 group on the left hand side of this carbon atom. Don't put anything on the left hand side. So take this CH3 group and bend it and draw it below this carbon atom. So let's put that together. That's CH3. So make sure that propene is converted into this form first, and then start drawing lots of repeat units. So I'm going to draw these propene molecules in this particular shape. Remember, I did not break any bonds. I'm just drawing a deformed version of the same molecule. So let's draw at least 3 repeat units. So here's another propene in its deformed shape. Nothing on the left or right side of the double bond. So I've drawn 3 repeat units. Remember, a polymer is going to have thousands of repeat units. So what happens now is the 3 repeat units would link up with each other. What happens is, under certain conditions, high temperatures, high pressures, the double bond breaks. If each double bond breaks, if all these double bonds break, each carbon would be short of 1 bond. If they are short of 1 bond, they're going to link up with each other. So now this carbon atom is making 4 bonds, and this carbon atom is again making 4 bonds. Suddenly they're going to link up with each other, and the linkages would keep on continuing. Remember, it's important to draw these continuation bonds. They show that the molecule is much larger than the one shown over here. There's a very, very long chain. So this is the molecule of polypropene. Now, in addition polymer, what needs to be known is that nothing is added or lost. There is no byproducts formed. There's nothing being added as well. It's propenes that are basically connecting with all the other propenes, and they're joining up and they're forming a linkage. So the ratio of carbon and hydrogen atoms in propene has a molecular formula of C3H6. You can count the total number of atoms. So there are 3 carbon atoms, and there are 1, 2, 3, 4, 5, and 6 hydrogen atoms. So remember, the ratio is going to be for carbon to hydrogen ratio, that's 1:2, or 3:6, that's 1:2. Now remember this, when you form a polymer of polypropene, or if you form any addition polymer, there's nothing being lost or nothing being gained. So it's just a bunch of propenes that are adding up. So the ratio of the atoms is going to remain exactly the same. It's going to remain 1:2. So for every 1 carbon atom, there are going to be 2 hydrogen atoms. So it's going to be, option A is going to be the correct option for this particular question.